Hello friends, welcome back to my YouTube channel. Today we are solving test 3 or internal test 3 of data science, and now let's start with our first question, that is question number 1. Discuss attribute by attribute problems that may be found into following database. We have given a database and we have to classify, or we have to find that the which problems may occur in this database. So let's first uh, see that which problems which may occurs in this database. We can see that clearly there is no problem in customer ID, but in zip code there is something like which contain alphanumeric words, and which is some is containing only 4 letters, which may create some problems in a database. And in gender there is also some, we can see that here is one null values. And in income here we can see that someone is put a minus mark in this, which can income which can't be negative, and someone is putting so high income and someone is putting very weird income. And in marital status we can also see there are some also anomalies. Now let's discuss one by one each anomalies in this database. The customer ID variable seems to be fine, but the attribute of zip, here we are expecting all of the customer in the database to have the usual 5 numeral US zip code. The customer 1002 is okay, but now customer 1002 has zip code of J2S7K7. Unusual value may be an error, and toss it out. Not all countries use the same zip code. Actually, this is the zip code of Saint Hanset, Quebec, Canada. So probably represent real data from a real customer. The customer 1003 is okay, but for customer 1004 we are unaware of any countries that have 4-digit zip code, such as the 6269 indicated here. So this zip code for the New England states begin with the numeral 0, unless the zip code field is defined to be character, text, and which is apparently what happened here. The zip code is probably 06269, which refers to stores Connecticut gender Connecticut. So in this way we have solved some problems. Now let's come to our gender attribute that contains a missing value for customer 1003. So this may create a problem. Now let's move forward to next attribute, that is the income field. And the income field is measuring annual gross income that has 3 potentially anomalies. First, customer 1003 has income of 10000 per year, possible, but especially when considering the customer's zip code 90210 Beverly Hills. This value of income is nevertheless an outlier, an extreme data value. Certain statistical and data mining modeling techniques do not function smoothly in the presence of outliers. Poverty is one thing, but it is rare to find an income that is negative, as our poor customer 1004. So, customer 104 reported income of minus $140,000 lies beyond the fields of bounds for income, and therefore must be an error. It is unclear how this error crept in, which with with perhaps the most likely explanation being that the negative sign is a stray data entry error. However, we cannot be sure and should approach this value cautiously, attempting to communicate with the database manager most. For customer 1005 income of 999, perhaps it may in fact be valid, but if all the other incomes are rounded to the nearest 50 codes, $50 codes for anomalous entries such as in missing values, perhaps 999 was coded in an old database to mean missing. Finally, are we clear as to which unit of measures the income variable is measured in. Database often get merged sometimes without. For example, it is quite possible that the customer 1002 with the Canadian zip code has an income measured in Canadian dollar, not US. So it may create some problems in the database. Now let's move forward to the next attribute, that is the age field. The age field has a couple of problems. Although all the other customers have the numerical values for age, but the customer 1001's age is C probably reflects an earlier categorization of this man's age into a bin labeled C. The data mining software problem somehow. Customer 1004 age of 0. Is it possible? Perhaps there is a newborn male living in Stars Connecticut who has made a transaction of $1,000 more. The age of this person is probably missing and was coded as 0 to indicate this or some other anomalous condition. Of course, keeping an age field in a database is a minefield in itself, since the passage of time will quickly make the field's values. It is better to keep data type fields such as birth date in a database, since they are constant and may be transformed into ages. Now let's talk about our next field, that is the metal status field. Metal status field seems fine, right? Maybe not. The problem lies in the meaning behind these symbols. We all think we know what these symbols mean, but are sometimes surprised. For example, cold water in a restroom is in Montreal and turn on the fucking marked C, since the C stands for Joe, which is French for hot. Thus, there is also the problem of ambiguity. In above table, does the S for a customer 1003 and 104 stand for single or separated? Now next comes the transaction amount field. That seems satisfactory as long as we are confident that we know that unit of measure is being used and that all records are transacted in this unit. Now let's move forward to our. In this way, we have discussed all the fields, all the attributes of the given database, and we have discussed all the problems in this database. Now let's move forward to our next question, that is apply data wrangling process in following database. So we have given again a database and we have to perform data wrangling. So we can clearly see that in this database the naming convention is disturbed. Here someone is using comma after name, and here someone is using their surname after their name, before their name. So we have to correct this, and here we can see that in 4 number field someone has used +91 in the starting, someone are keeping brackets before the code, and someone are simply writing the values, and in here is someone are using only 7-digit phone number, which may be a problem. And in birth date field also all are using different types of data formatting. And in state field here is nothing much problem, but what does TN means? It is Tamil Nadu or something else. We have to classify this also, or we have to correct this also. So let's perform some data wrangling process in this given database. After performing data wrangling process, we have created this database. What we have done in this, first we have all names are for now formatted the same way, first name and last name. We can see that we have formatted all the names as first name and last name, and we have also phone numbers are also formatted the same way, first area code, then ABC, then XX. We have formatted the our phone number also. Then dates are formatted numerically in the format of YYY, MM and DT. And states are not abbreviated. States are not abbreviated, they are complete named. And the entry for Jackie Agarwal didn't have fully formed data. The area code of the phone number is missing and the birthday had no year. So it was discarded from the dataset. Now that the resulting dataset is clean, readable for deployment or evaluation. In this way, we have performed data wrangling process on this database. Now let's move forward to our next question, that is question number 3. In this question, we have to consider following database and apply any three methods for finding out the missing values. We have to perform three methods to find out the missing values in the database. In this database, we can clearly see there is two missing values. That is, first is A2 attribute of ID2 and A4 attribute of ID4. So to find out, we can missing data is a problem that continues to plague data analysis method. Our aim to handle these missing values in fields, especially in database with a large number of fields. The absence of information is really beneficial. All things being equal, more data is almost always better. Therefore, we should think carefully about how we handle the thorny issues of missing data. Consider car dataset. A common method of handling missing values is simply to omit from the analysis the records or field with the missing values. However, this may be dangerous since the pattern of missing values may in fact be systematic and simply deleting records with missing values. Further, it seems like a waste to omit the information in all other fields just because one field value is missing. Therefore, data analysts have turned to methods that would replace the missing values with a value substituted according to various criteria. First is replace the missing value with some constants or specified. We can create some constant for this for these attributes to replace. For we can create for A2 0 value, and for A4 we can create NA or some constant like uh, any other state NA or unknown that may be uh, put on in this database. Secondly, we can use a mean or mode method. Mean and mode method, we will calculate the mean of these values and put the value of that mean in this box, and for this we will calculate the mode, as in this mode is gen, so we will put ogen in this block. And the third is the where the random draws from the distribution of the from we have the distribution of these values, and we can randomly draw any value and put it here. So for example, we draw 400 and put it here to create a normal distribution, or in this we can take Itanagar or Jaipur as from randomly draw from these values and put it here. This is our third method to handle the missing values. In this way, we can come do this third question. Now let's move forward to our next question, that is question number 4. We have to classify bank loan applications by assigning applications to one of the three risk class, that is A, B or C. We have to use entropy and gain approach, information gain approach. So let's start with the solution. This is the given table which is given to us. Now first we will calculate the overall information in the given data due to uncertainty of outcome regarding the risk class each person belong to. Uh, so first we have number of examples is 10, and in this we have number of classes 3, in from which frequency of class A is 3, frequency of class B is also 3, and frequency of class C is 4. Now we will calculate the information of the given data before the performing the splitting attribute. So in we have got 1.57 as our information. Now let us consider using each attribute in turn as a candidate to split the example. First we will take our home attribute. For value equals to y, there are 5 applicants who owns home. They are in classes A equals to 1, B equals to 2, C equals to 2, and for value equals to n, there are 5 applicants who do not owns home. they are in classes A equals to 2, B equals to 1 and C equals to 2. We will calculate information for separate y and n, which we got 1.52 and 1.52, and in the now we will calculate the total information of the two subtrees, that is 0.5 IY plus 0.5 IN, and that we got 1.52. Similarly, we will calculate for married attribute and gender attributes. For y value equals to y, there are 5 applicants who are married. They are in classes A equals to 0, B equals to 1 and C equals to 4. And for value equals to n, there are applicants who are not married. They are in classes A equals to 3, B equals to 2 and C equals to 0. We will calculate we will calculate separate information for IY for y and n, that we got 0.722 for y and 0.971 for n. Now we will calculate total information of the two subtrees, that we got 0.846. Similarly, we will calculate for gender attributes. There are three applicants who are male and they are in classes A equals to 0, B equals to 3 and C equals to 0. And for value equals to n, there are 7 applicants who are A equals to 3 and C equals to 4. In this way we will calculate the y and information gain of information of y and n, and at last we will calculate total information of both y and n. And similarly we will calculate for other attributes also, and we will make a table like this, in which we will firstly we have already calculated the information before split, and then we have also calculated the information after split that we got in the previous slide. We will subtract information after split from information before split, and in this way we will got our information gain. The attribute with the highest information gain will be selected as our splitting attribute. In this scenario, gender is the attribute with the highest information gain, so it will be selected. And now we can reduce the data by removing the attribute gender and removing the class B, since all class B have gender equals to male. So we have removed all class B members. Now our table is reduced to this table. Now we will again calculate the information before further splitting the table, that we got 1.33. Let us now again consider each attribute in turn as a candidate to split the sample. Again we will perform the same methodology. For first, for home attribute, for value equals to y, there are three applicants who owns homes. They are in classes A equals to 1 and C equals to 2. And for value equals to n, there are four applicants who do not own home. They are in classes A equals to 2 and C equals to 2. And again we will calculate information of separately y and n, and we will calculate total information of the two subtrees, that we got as 0.96. Then we will move forward for married attribute, and we will find that for value equals to y, that there are four applicants who are married and they are in classes equals to 0 and C equals to 4. And for value equals to n, there are 5 applicants who are not married. They are in classes equals to 3 and C equals to 0. We will again calculate separate IY and IN, and then we will total information gain. In this scenario we have got 0 total information after split. It means that it is the best attribute for the split, because it will give the maximum information gain when we subtract 0 from the information before split. So without further checking, we will take married as the verb. Next attribute, here it is written that there is no need to consider other attributes now, because no other attributes can be better the split attribute than married. So we will use this as split attribute. At last we will generate our rule as, if gender equals to male then class B, else if married equals to yes then class C, else class A. In this way we have generated the rule using entropy and information gain. Now let's move forward to our next question, that is question number 5. We have to compare the attributes for classification of bank loans of applications by assigning applications to one of the. We have to do again similar task, but this time we have to use Gini index and information gain approach. So for this we have given the same table. Now we will perform again. We will, in this method, first we will calculate the Gini value of index of further distribution of applicants in the three classes that we got as 0.66. The formula for calculating Gini index is that 1 minus pi square, where pi is the proportion of each class. So now we will move forward and we will consider each attribute as our candidate for splitting, and we will calculate their Gini index. So first we will take our home attribute, and here we got that for value equals to, there are 5 applicants who owns homes. They are in classes A equals to 1, B equals to 2, and C equals to 3, 2. And for value equals to n, there are 5 applicants who do not own home. They are in classes A equals to 2, B equals to 1, and C equals to 2. We will calculate separately Gini of index of y and n, and then the total value of Gini index, as we have done in our entropy method, and we have got 0.64. And similarly we will calculate for married and gender, that we got 0.40 and 0.358. In this method we select the attribute which has the minimum Gini index after split, or which has the maximum gain after split. So in this scenario we again got the same gender attribute as our appropriate attribute for split, and we will take it as our splitting attribute, and we will further reduce our table and remove our class B. All things will be similar as we have done in our entropy and information gain, but only there is the difference of the formula. The attribute with the largest rejection in the Gini index is selected as the split attribute. So the gender value was male out of consideration, since they have already been classified. The tree obtained for his example is exactly the same as the information gain. So I think you all have understand that how we have to perform this Gini index problem with information gain. In this way we have completed our test 3 of data science. Thank you.